Okay, let's continue with the Proteus simulation for stepper motor. So we are going to use again the same concept. So we have the PIC16F877A, and then you have to design the motor. Then you have to search for motor, stepper motor. So here, then you take the unipolar stepper motor model, which is this one. It has six pins, six connections over here. Two will be going to the ground, and the other four will be going to be connected directly to the PIC. Okay, so this is a basic simulation that I want to do, because this is I just want to show, because we should have the L293D also to be used to drive the stepper motor, because normally the stepper motor will have the rating power more than 5 volts, not power, the voltage power, the voltage is going to be more than 5 volts. And also we need to control the speed of the stepper motor by using the PWM through the through the L293D. So before that, because of the simulations in Proteus is only for 90 to 45 degree step angle, then it's quite hard for us to look at the results on the speed of the stepper motor. So it can be tried on the hardware, but at the moment we cannot use the hardware, so we are going to try to use it on the simulation procedure. Okay, let's try to work on the first drive here. And the first drive here that we learned before is this one. So we have the 0001. This is the case, right? So we're going to have the step angle 90 degree and 4 per revolution. So let's try to connect first. I want to use RB0 to RB3 to be connected. So according to this one, so this is going to be the first pin. The second pin will be here. The third pin will be here. And the last pin will be here. All right. The next two will be going to be ground. So I'm going to put ground here. And this is going to be connected to ground. All right. So now we have this RB0 to RB3. So port B is going to be output. So let's try to write down the program. So you have your macro C. This is the original one. So start with a thrice B is equivalent to 0B00000000. So this is the one that I declare my port B as the output. My first initial value for port B is all 0 volt. Is 0B 00000000. Then you have the while one loop. Then you have the bracket here. Okay, this is the one that we are going to put inside here. So the first pin will be port B F0. F0 is equivalent to 1. Then the next one is a port B dot F1 is equivalent to 0. Next one is port B dot F2 is equivalent to 0. Then the last one, port B pin 3 is equivalent to 0. So this is the first drive that we're going to use. So the first drive say that it's going to be like the same thing. I'm going to start here 1, but doesn't matter. I'm going to start here 1 0 0 0. Then it's going to be have this sequence. So I can just copy this one, copy. Then I'm going to change this one accordingly. This is going to be here 1. This is going to be here 1, and this is going to be here 1. All right. Okay. So I think it should be okay now. So let's try to compile this one, build. Is there any problems? So no problem. So I'm going to run it in my in my Proteus. So let's run it. So you can see that there's very fast. I mean, the triggering is very fast until you cannot see the movement of your motor here. So you need to add delay to have a simulation and to look at the results, because this is just simulation, not the real one. So let's go for your micro C again. So let's put here delay ms. Maybe you can put 1 second. So copy all this. All right, so compile again. All right, see what's the results. Okay, rest on this one. Now you can see your stepper motor is rotating. So let's calculate the step angle here. So what do we have now is let me draw, just get some drawings over here. PowerPoint. Okay, so you have the value here. Every stepping is let's take the stepping value here. The first stepping value is this is one is negative 45, then negative 135, negative 225, and the last one is negative 315. All right, so that is the one. After 315 is negative 45 again. So okay, let's see 315 the minus 135. So this is 0, this is 2, this is 90, is it? 315 minus 135. I just use calculator. 315 minus 135. Sorry, not this value. Sorry. I should take this one. 315 minus 225. So this is 0, this is 2, this is 90 degree. So it's correct. So you can see that by having each of the step here, you have this pulse here one by one. You can see that this is also 1, 1, 1. Then this is your stepper motor rotating at 90 degree step angle, which is proof this process. Okay, so let's look at the second one. Second one, you have to have this one 0, 0, 1, 1 like this. So 0, 1, 1, 1. So let's try to have your code to be changed like this. So it's 0, 0, 1, 1, 1. I just want to follow this one. It's much easier for you to have a reference. This is 1, 1. Then you have 1, 1 here. Then the last one you have 1, 1 down there. This is 0. This is 1. This is 0. Right? This is correct. 1, 1, 1, 1, 1, 1, and 1. So let's compile it. Build. Then run this one. Okay, let's start to see it. You can see that the red color is like this too. Then here. So this is double stepping, right, just now? Okay. So you can see that now we are going to calculate the value. So the step angle 3, okay, is still 90 degree difference, right? So you can see that it's 90, 180, 270, and 360 is 0. So this is the second stepping. You can see that this is the one, and the value is not just now that we have 2 to 5, right? This is actually another stepping. For example, like this one just now, you can see that the stepping is like this. Okay, and here is like this, right? So it's a bit different. That's why the value here is not directly like just now is 315 225. Here is much direct, is 090, which is the same like this one, 090. This is the one that we are running. Okay, and the last one you have to follow this one. So you're going to do this one. I have my own code, so I'm going to post it over here. Okay, I'm going to have it over here. So it's going to be eight lines. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Okay, let's look at the results. I'm going to build this one. Okay, so just run this one, and you can see that the value is like this: 2 to 1 2 1 2 1 2 1 2 1. So let's look at the value of the rotations. It starts from 0 and then 45 and then 90. You can see that the step angle now is actually a 45 degree. So it's 8 per revolution. So this is a smaller stepping size, step angle. So it more precise compared to the first two simulations that we have. So this simulation is only for us to look at these results only. All right, we are going to have a real one in the hardware which have different step angle that you can control basically like this. Okay, so this is a direct version. Okay, because the fourth one just now is micro stepping, which is I don't use it in my PIC. So here is a direct stepping to show that you can directly trigger and give a pulse to control your stepper motor. But this is not the real life that you can do it, because you must use a driver. So let's stop this one first. The connection must be like this, and then you have to run, and then you have to edit your code to make sure that it works correctly. So I'm going to move this one here. Then you have to find the driver, L293D. This is the driver, the same one driver that we have used for the DC. Okay, this is the case. So you have the RB0 just now start, right? So go for in1, and then you have the in2, and then you have the in3. So this is enable, sorry. Then you have the in3 here, and then you have the in4. 1 2 connected to here, 1 and 2, right? Then you have 3 and 4 here. All right, you have these connections done. Then you have the ground. You must ground your driver. There's a ground here. All right. Then again, this is the one that I have a mistake last time. So VS is going to be the battery. So this is going to be a power here at VSS. Power must be here. This one you can use battery. So what's the value here? This is 12 volts. So you can put 12 volt battery. Right, this is a battery. DC voltage, I think. Better, yes. Okay, so this is a battery. And then this is ground, directly to ground. Common ground. Okay, so this is a concept that you have to put first, and the enable 1 and enable 2 must be coming from the PWM. So for example here, if you want to use PWM1 CCP1, you must connect to here, and then this is going to be the same shared lines. Okay, so this is the CCP, the PWM that you want to control. Okay, let's try. Let's try. I think we can try here, and let's try to have a look only 4. I'm not sure whether it's working or not on that one, so it's okay. So we just want half here, 1 1 0. This is going to be 0. This is going to be 0. This is going to be 1. This is a single stepping. This is 0. This is 0. This is 1. So we have to start the output at try C. Try C is equivalent to 0B. All it will be output. And then you have the pop C. All now is going to be all 0 volt. Then you have to start the PWM, right? So let's go to the PWM library. So we have to initialize this one. Right here, we have to initialize and start, right? Remember that we have to start it. Right, is it still okay? Build. So it's not found here. So okay, this is because of this one. So let's run again. All right, it's working because of the library already been library manager here. Yeah, everything is everything is checked. So right now we are trying to set the duty, right? Set the duty. Let's try set duty 1. So 255. Set duty 1 here. So let's try to put a full value 255. 255. So is it correct or not? I just want to try first over here. Let's have a look. Okay, is there any problem? No, no problem. So just build this one, and then we're going to run it. Stop this one. We're going to run this one. So it's working, right? Oh, I'm going to change the sorry. I'm going to remove this one. The milliseconds there is very long already. So let's try to remove this one first. Let's see what happened. Because right now the speed, I will control it from the PWM, not from the time delay anymore. Is there any problem for the macro C? Alright, no problem. So yeah, that's the case because even though we use the CCP pins over here, right, it does not work correctly. The simulation is not working correctly. So let's try to change the CCP directly for this one, go to direct. Okay, means that I put 5 volt to the CCP pins, to the enable, which is controlling the speed of the motor. This is very fast already, right? So the motor cannot move, and it's moving very fast here. So I still have to put the delay. So maybe around 5 seconds, 0.5 seconds. Okay, let's look at the result. So I remove back this one. I just want to go back to CCP pins 1 here. All right, this is the one. Let's try. Yeah, it's still moving anyway, which is around 45°, which is a 90° difference. All right, so I just want to take this one back, directly go to the 5V here. It's much faster, you can see that, because it's always 100% 255. It's much faster because this is the animal pin receive a direct 5V, means it's always high. So this is going to be a full speed of your stepper motor, right? So maybe I can remove this one. I'm not so sure. Let's see, this is working, right? Because we have a delay over here. So let's remove this delay. What happened if this is delay is going to remove and the simulation is not working, means that we can understand that you have to use on the hardware to work with the driver to control the speed of the stepper motor. So let's run this one build again. Okay, let's run again. Yeah, without the delay just now, you can see that the motor is not moving. Even though you actually give the right stepping, you can see that stepping is working by sequence. But because of the very fast, then you cannot see the simulations correctly. That's why we have to put delay over there. So I'm going to put back the delay. So this is the one. You can build this one and run again. So stop this one. Run again. You can see that this is the one is moving back correctly. All right. Again, L293 is compulsory if you want to run. You must have a driver to run your stepper motor on the hardware. But on the simulation, we have problems here because this is not actually showing us the stepper motor speeds over here. But again, PWM can be given to the driver itself, and then this can be controlled, can control the speed of the stepper motor. All right, this is the method. So hopefully that you can find try yourself and understand the concept here. Okay, that's all for the stepper motor driving using the PIC and the simulations on Proteus. So thank you very much. Have a good day.